Hi there, welcome to Eduretics, where we make your high school life simple. I'm Aniket and welcome back to the Digital SAT Math Practice Series. So right now we're doing Advanced Math section, and in that, this is the part 2 of the medium difficulty for nonlinear functions. Make sure you practice alongside, pause the video, check the answer, and then only look at our solution. Let's begin. Let's look at question number 1. From 2005 through 2014, the number of music CDs sold in the United States declined each year by approximately 15% of the number sold the preceding year. In 2005, approximately 600 million CDs were sold in the United States. Of the following, which best model C the number of millions of CDs sold in the United States T years after 2005? Okay, so they've given the initial value and then supporting information. So let's see. Initial value is 600 million CDs, which begins in 2005. Okay, and then each year, so from 2005 through 2014, it declined each year by approximately 15%. So there's a 15% decrease each year. So in 2005, if it was 600, then in 2006, it's a decrease of 15%. So 600, 1 minus 15 over 100. That's how we find out the decrease. We just reduce 15% of 600 from 600. That is the initial value. Okay. So then this becomes 600 times 0.85. This is for 2006. 2007, 15% decrease in this complete value. That means this multiplied by 1 minus 15 over 100, which is 0.85 again. Okay, so now this becomes 600 times 0.85 squared. And if you see, from 2005 to 2007, we've taken a time gap of 2 years, which is also the power of this percentage. So that means as many years pass, that would be the power on top of this 0.85, which is the final value after the decrease. So after t years, it's going to be 600 times 0.85 raised power of t. So let's look at the options. It's B. Option B is the correct one. Okay, let's move on to the next one. The product of two positive integers is 546. If the first integer is 11 greater than twice the second integer, what is the smaller of the two integers? This is a good question. The solution would be short, but it's very important that you properly translate what's written in words into mathematical equations. So linear equations. Product of two positive integers, let's say the two positive integers are x and y. Okay. First integer is 11 greater than twice the second integer. So x is 11 greater than, so y plus 11 greater than twice the second integer. That means 2y plus 11 greater than twice the second integer. What is the smaller of the two integers? So now we have these two things. We have x in terms of y and y is there. The product of them is 546. So we can form the equation as x times y is 546. Put the value of x in terms of y. 2y plus 11 times y is equal 546. Okay. Now make the equation from here. 2y times y, 2y squared plus 11y is equal to 546. Okay. So 2y squared plus 11y, 546. Bringing them all on one side, on the left hand side, we get a quadratic equation, a nonlinear function, which is a quadratic equation. Okay, now let's see how to solve this. So 11 is in the middle. We'll take the product of a and c. So 546 times 2 in the negative. Or we can even do squares. Let's do a direct one. Let's use the quadratic formula. Minus b plus minus square root b square, 11 square is 121, minus 4ac, that means it will be plus 4 times 2 times 546. Since 546 had a negative sign already, so it becomes plus over 4. Okay, so 4 times 2 is 8. 8 times 546. 500 times 8 is 4000. 40 times 8 is 320. 6 times 8 is 48. Okay, so this is going to be 4368 plus 121 is going to be 984 4489. That's the thing inside the square root symbol. 4489. Let's see what's the square root of 4489. Looks like a perfect square. So 4489. This will also quickly give you an idea on how to find square roots. So pick 44. 44, the square nearest perfect square is 36. So 6 times 6. 36. 44 minus 36 is 8. 8, and then bring down the 89. 889. Double the thing you got here. 6 becomes a 12. Now we need one digit here, such that 1 to 120x, let's say 126 or anything. If we take 126, it should be multiplied with the same digit, that is 6, and the answer should be 889. So I'm figuring at the end we need a 9, so it could be 127. 127, because only two numbers are there which one multiplied by themselves give a 9. 3 and 7. 3 times 3 is 9, 7 times 7 is 49. 127 times 7, let's check. 7 times 7 is 49, 9 carry 4. 7 times 2 is 14, 4 18, 8 carry 1. 7 times 1 is 7 and 1 8. Perfect. So it's 127 and 7. This here is the square root of 449, 67. Okay. It's a quick practice. I can make a separate video on how to find the square roots. If you need that, let me know in the comments. I'll post another one for that. See, that is the benefit of these problem solving videos. You get to learn a lot of mixed concepts just while solving these problems. Okay, so 67 would come inside. Negative 11 plus minus 67 over 4. So it's at positive integers, so we discard the negatives all through. So negative 11 minus 67 is discarded. Negative 11 plus 67 is the thing. So 67 minus 11 is 56 over 4 is 14. 14 is the value of y, and x is the bigger one. X would be 11 greater than twice, so 14 times 2 is 28 plus 11 is 39. So the two integers are listed here, 14 and 39. This is the correct answer. The smaller one is 14. So B is the correct answer. Okay. Next question. Y is equal to 4 times 2 raised power x. Which of the following is the graph in the xy plane of the given equation? Again, a nonlinear function, which is an exponential function here in this case. To draw the graph of any given function equation, it's very important to get an idea of what kind of values is it attaining on the y-axis corresponding to the x-axis. So we'll do a similar analysis here. There's a standard way to graph the exponential functions. We'll see that as well. So y is equal to 4 times 2 raised power x. If I look at x is equal to 0, if I put x is equal to 0, what is y equal to? Solve it quickly. 2 raised power 0 would be a 1. 1 times 4 would be a 4. Y is a 4. If I look at x is equal to 1, y is going to be 2 raised power 1, which is 2 times 4, which is 8. X is equal to 2. Y is going to be 2 squared, which is 4 times 4 is 16. You see, it's increasing. It's increasing at not a constant pace, but even the rate of increase is increasing. 4 doubles to 8, doubles to 16. It keeps on doubling. Okay. So this gives us an idea that this is going to be an increasing graph. Okay, it's an increasing function. Now if we look at our options, option A, it's coming from positive infinity on the y-axis, settling down to 0 on the x positive infinity. It's a decreasing function. As you can see, it's a decreasing function. not the correct answer to our question. Option B, again, coming from a higher value on y-axis, eventually settling at at y is equal to 0 on the positive infinity. This is basically the horizontal asymptote. This is called an asymptote where the graph settles. So option B is again a decreasing graph, not allowed. Option C is increasing. You see, it begins from 0, y is equal to 0, and then it catches pace and goes on till infinity. Option D, same thing. Increasing, goes on. The only difference between option C and D is the steepness of the graph. How fast the values are increasing, the steepness of the graph. So for that, we'll take an idea of the values given here as well. Okay, we cannot just take a random assumption that 4 times 2 raised by x would be option C or D. We'll take a look at the values. So if you see on option C, x is equal to 3, it's nearing y is equal to 100. Let's check. If I put x is equal to 3, 2 times 2 is 4 times 2 is 8, 2 raised by 3 is 8, 8 times 4 is 32. It's not reaching 100 there. So option C is wrong. Option D, let's see, at x is equal to 4, it's nearing about 60. As you can see here, this is the point where it intersects. It's nearing 60. Let's check. X is equal to 4, 2 times 2 is 4 times 2 is 8 times 2 is 16, 2 raised by 4 is 16, times 4 is 64, which is approximately 60. Yes. So option D is correct. This is how you qualitatively analyze a given function or the graph of it. Okay, so a lot of times you would be asked questions where you can directly just look at the nature of the graph and answer. So for example, the nature of the graph in our question would be an increasing graph starting from 0 on the negative x axis, 0 I'm saying for y, and going all the way till infinity on the positive x axis. Okay, so this is the nature of the graph. It's an increasing function. It starts from negative x infinity from y is equal to 0, goes on up to the positive y all the way till infinity on the positive x axis. Okay. That's the nature of the graph. But in this question, we also needed to see the specific values. So you can find both of these questions. The key is, whenever you get questions where you need to look at the values, do a qualitative analysis of this kind, the way I did just now. And whenever just the nature of the graph is asked, you must have the transformations, the function graphs on your fingertips. For example, 4 times 2 raised by x. So this is similar to k a raised by x. So a raised by x, when a is positive, will always be like this. When a is greater than 0, greater than 1. When it's between 0 and 1, it will be a decreasing graph but positive. When a is between 0 and 1. So a 0 and 1, a greater than 1, it will be increasing. Okay, I'll put up a similar video dedicated to this one. Put it in the comments. Just let me know if you need it. Okay, for the graphs. Let's look at the next question. The function f of t is equal to 60,000 times 2 raised by t over 410 gives the number of bacteria in a population t minutes after an initial observation. Okay, it's like the population is exponentially increasing, as you can see from the nature of the equation. And in the last question, we did a similar thing. K a raised by x, similar to that, this function is. How much time in minutes does it take for the number of bacteria in the population to double? Okay, so how much time does it take to double the population? Sure. So f of t is given to us as 60,000 times 2 raised to the power of t over 410. Okay, we need to double it. So let's say at t is equal to let's say t naught, or at t is equal to 0. Let's say what's the population at t is equal to 0. Let's take that. T is equal to 0, f of t would be 2 raised by 0, which is 1, 60,000. So initially it is 60,000. That's what we know. Now to double this, that is, it becomes 120,000. What do? So we form an equation. Let's say the value is 120,000, value of f of t, and f of t is defined as 60,000 times 2 raised to power t naught over 410. We say that at t is equal to t naught, the population is going to double. It becomes 120,000. Now from this equation, we need to find the value of t naught. Okay. So 60,000, 120,000. These can straight away be cancelled. Okay. And this becomes a 2. 2 raised power 1 is equal to 2 raised power t naught over 410. Compare on both sides. This is just a simple exponent equation. The bases are same, powers must also be equal. 1 is equal to t naught over 410. So t naught is equal to 410 minutes. In minutes, the answer is going to be 410. In hours, it's going to be 6 hours and 15 minutes. Okay, or 6/5 by 6 hours. So that's the time taken. This is how we solve simple exponent equations. Okay. Next question. The height in feet of an object x seconds after it is thrown straight up in the air can be modeled by the function h of x is equal to negative 16x squared plus 20x plus 5. Negative in the coefficient of x squared suggests the parabola opening downwards, which must be the case because when you throw something upwards, it forms a downward opening parabola. Based on the model, which of the following statements best interprets the equation h of 1.4 is equal to 1.64? Okay, so they've modeled the motion of an object x which is thrown straight up in the air, so it'll be traveling like this, a parabolic motion. Okay, a parabolic or a projectile motion, whatever you can say. So since it's opening downwards, the coefficient of x squared will be negative. Just quickly revising our quadratic equation concepts. Now based on this model, which of the following statements best interprets the equation h of 1.4 is 1.64? So what are we placing 1.4 as? We're placing it as x. And what is x? Of an object x seconds after it is thrown. So x is the time elapsed after it is thrown. So it's basically saying after 1.4 seconds of throwing it. So 1.4 seconds after the object is thrown. The height, what is it modeling? The h of x is basically the height in feet. That means it's attaining a height of 1.64 feet after 1.4 seconds of throwing it straight up in the air. So the height of the object 1.4 seconds after being thrown straight up in the air is 1.64 feet. Option A is the correct one. Yes. Okay. So this was a simple interpretation question, but you'll get to see a lot of these on the paper. Like these are popular questions where they want you to interpret because functions, equations, graphs, these only make sense when you're able to relate them to the real life scenarios. It's really important. Okay, let's look at the next question. fx is equal to x squared minus 18x minus 360 if the given function f is graphed in the xy plane where y is equal to f of x. What is an x-intercept of the graph? Pretty simple. Okay, they've given you a quadratic function x squared minus 18x minus 360. The coefficient of x squared is positive, so it's going to be an upward opening parabola. And what's the meaning of, it's asking what is an x-intercept of the graph. So for this we just need to know what are intercepts. If someone says x-intercept or y-intercept, what does that exactly mean? It means, so when we ask x-intercept, it means the value at the value on the y-axis when the graph cuts the x-axis. Okay, so for example, this here is a graph. Okay, so this is the x-intercept. Okay, this is the x-intercept. So x-intercept means when y becomes 0, when the value on y-axis is 0. Y-intercept, where it cuts the y-axis, that means where the x is 0. So very simple, whenever you want to find the x-intercept, that means you're placing y is equal to 0 because your graph must cut the x-axis. If it's cutting the x-axis, it's touching the x-axis, that means y is 0. Similar for y-intercept. You need to find the y-intercept, it must cut the y-axis, and x must be 0 at that point. So they're asking for the x-intercept. That means y is equal to 0. As you can see in the options, it's evident. All options have y is equal to 0. So let's check for what value will y go to 0. So in this case, x squared minus 18x minus 360 is equal to, this is the y value, f of x, should be 0. So they're basically asking us to solve the complete quadratic equation. As simple as that. Why? Because if you look at the graph of the quadratic equation, it is like this. So the intercept here, there are two x-intercepts, a and b. Value of the a-intercept is basically the first root. Value of the b-intercept is the second root. So we just need to find both the roots. So 360, let's split it up into two parts. 360 can be written as 18 times 20, or we can break it down further, 9 times 2 times 4 times 5, and see what adds up to negative 18. So let's split it up further, 3 times 2 times 4 times 5. Now let's see. So 3 times 4 is 12, times 3 is 36, 5 times 2 is 10, or 3 times 3 is 9, 3 times 15, times 2 is 20. Yeah, this is what it means. 3, 5 and 2, we combine. 3 times 5, 15, times 2 is 30, 3 times 4 is 12, 30 and 12. X squared minus 30x plus 12x. Don't try to do guesswork right away. It might take some more time. Rather try this prime factorization. It's more beneficial, even though it looks like it was pretty easy and could be done verbally. X squared minus 30x, x minus 30 plus 12, x minus 30 is 0, x is equal to negative 12 and 30. What is an x-intercept of the graph? Negative 12 is the correct answer. Option A, because we have negative 12 and 30. 30 is not there, negative 12 is there. Okay. So this is how we are concluding the part 2 of medium difficulty. Make sure you practice these questions. As a habit, just practice questions from one video each day. You'll be all set for your digital SAT math. We've covered all kinds of questions which will be coming topic wise. Okay, so stay tuned for the next part, which will be hard. The hard part 1 would be coming out in a few days. Yeah, again for nonlinear functions. Stay tuned. Bye bye.